Hello, hello. We are starting with a brand new unit today. So we are going to be taking a look at exponential laws, okay? Exponential laws. So like adding, subtracting exponents, what happens when we divide, like bases, things like that. So as your very first do now question, okay, so again, we're going to be taking a look at applying the properties of exponent rules to evaluating and simplifying expressions. So I want you to take at this do now question, take a look, and see if you can come up with, is this example here, is this an exponential function? Why or why not? I really actually want you to think about this. Is y equaling 1 to the x minus 2? Is that an exponential function? Why or why not? Take a few seconds and think about it. Write down what you think. So pause the video here. You think you got it? Oh, I see someone raising their hand in the back. What do you think? Okay. Yes, you are correct. No, this is not an exponential function. Guys, what's 1 to the x? What if x is 2, 3, 4, -1, -2, ... 1 to the anything is 1. 1 to the third is 1. 1 to the negative third is 1. That's just 1 over 1 cubed, which is still 1. So whatever we raise 1 to, it's always going to be 1. So 1x to the first is equal to 1. So y equaling 1 to the x minus 2 is really just 1 minus 2, which is -1, which is a constant function. So no, we end up getting y equals -1, which is a constant function. Okay, there's no exponential function going on here. This is what an exponential function looks like, where we're looking at b being either greater than 1 or less than 1. But if it equals 1, we're going to end up getting whatever this is to the x power of it being 1. Okay, so can we go back and just think about what is the negative exponent rule? Does anyone remember? I actually kind of just did it already. If I have like a to the negative x, what is that written as with positive exponents? What would that look like? That'd be 1 over a to the x. When we have a negative exponent, we drop it into the denominator and make it positive. So that's our negative exponent rule. All right, let's get into the nuts and bolts of all of these different rules for exponents. Woohoo! All right, so hopefully remember, and if we don't, that's why we're going through it. When we multiply like bases, so x is our base, multiply like bases, you add the exponents. Keep the base, so the base is x, add the exponents. So I would have a plus b. All right, I'm just zooming in here. So again, x is the base, a and b are the exponents, keep the base, add the exponents. Let's take a look at our next example. X to the a power over x to the b power. When we divide like bases, keep the base, subtract the exponents. Subtract the exponents. Okay? And now when I have a power to a power, so I have x to the a all to the b, we multiply. So this is x to the ab, not to be confused with addition here, multiply them. And if I have x times y all to the a, that a applies to the x and the y. So that's really x to the a times y to the a. We distribute that variable into both. Sorry, that was written a little sloppy. We distribute that variable into both. Okay, let's keep going. We've got number 5. If I have x over y to the a, again, that a applies to both numerator and denominator. So this is really x to the a over y to the a. These are important rules for us, people. Question 6, we just did this. This was question 2 at the very top. What's the negative exponent rule? So this is going to be 1 over x to the a. Really important rule. Really important rule. All of them are important. And then anything to the 0 is 1. All right, so there are all your rules for exponents. So let's actually start applying these rules. So if I look at the bottom here, this first exercise. Solve each of the following by writing all exponents in expanded form and then rewrite into one exponent. So let's see. 7 to the 4th times 7 squared. We have like bases being multiplied. So I'm looking over here at this rule. That means we add the exponents. So I'll have 7 to the 4 plus 2, which is 7 to the 6th. Okay? I have 3 to the 5th times 3 to the 1st. Again, they're being multiplied. So we add the exponents. And we know 5 plus 1 is 6. Okay. Let's keep going. Let's see. We have y to the 7th over y to the 3rd. So now we're looking at division. When we have like bases, subtract the exponents. 7 minus 3 is 4. So I have y to the 4th. And then lastly, again, like bases are being divided here. So we subtract the exponents. 4 minus 6 is negative 2. So I have 8 to the negative 2nd. And I want to write it with positive exponents. So now we need to use this rule over here. I have x to the negative a, right? We got that negative exponent. We bring it down. So this is going to be 1 over 8 squared. And that's it. Alrighty, let's flip it over. Remember, we're going to need to refer to those rules, so make sure you have them handy. Okay, so we actually already just talked about this. But when we multiply terms with like bases, right? You keep the base and then add the exponents. Okay, keep the base, add the exponents. When we divide, okay, so this one was multiply. When we divide like terms with like bases, keep the base and subtract the exponents. All right, I'm just reiterating all the facts we just talked about. If you have a negative exponent, you can rewrite it as a positive exponent, but you must move it into the denominator, okay? Or the numerator. It's actually going to depend, right? It's actually going to depend. You could see something like this. And to get rid of that negative exponent, we would actually raise it up. So it's just flip-flopping. And now if I have a power raised to a power, we multiply the exponents. Multiply the exponents and raise the power to the outside of a positive exponent. Okay, you must move its position in the fraction again if it's negative, things like that. All right, so why don't you try A and B? Why don't you try A and B using these rules? So I have 4 to the negative 2nd power. I want to rewrite it with a positive exponent. I have 8 to the negative 6. Rewrite it with a positive exponent. Okay, good. You should have gotten 1 over 4 squared. 1 over 8 to the 6th, right? We're just moving the position. But now this pertains to what I was just talking about in this example here, right? Now I have the exponent being negative in the denominator. So to get rid of this negative exponent here, right? To get rid of that negative exponent, we're just going to bring it up to the numerator. And now it's positive. Same thing over here. I have a negative exponent, right? I've got 5 over x to the negative 7th. I need to raise it up into the numerator, and I will make it positive. So those are my two answers. Okay. And let's see. Lastly here, just a reminder, that power to a power rule, right? When we said we multiply the exponents, and then just raise that power to the outside power, multiplying. So that you'll see here in parts A and B. So that's the power to the power rule, right? You see how this 4 is on the outside? It actually applies to both. So we'll have 2 to the 4th times x to the what? It's a power to a power. X cubed to the 4th. That's really x to the 12th. Same thing with how we could have written it out here. This is really 2 to the 4th. Okay, that's just separating it. I could have done that here as well. I could have separated this into x squared to the 3rd times y to the 3rd. And again, that power to a power, we multiply. So that's x to the 6th times y cubed. Okay, now you'll see in this unit packet there are a whole bunch of examples. I am not going to go through all of these. This is just a lot of extra practice for you all. There's a lot of practice here. Okay, tons and tons of practice. I'm actually going to have us skip all the way to page 7. So see all this practice. Okay, we're going to do more practice. Lots of practice here. Okay, skipping all the way to page 7. So let's get started. All right, we're going to simplify. I have 2k to the 4th n times negative 3k cubed n squared. So let's see. I'm just going to write this out. Always like to rewrite. They're being multiplied. Got those parentheses going on. And let's see. We've got 2 times negative 3. That's negative 6. Multiply our like bases. So I have k to the 4th times k cubed. They're like bases being multiplied, so we add the exponents. And what else do we got? We have n. Oops, did not mean to erase that. Sorry. That was n times n squared. Remember, this is to the first. Multiply like bases, add the exponents. Simplify this, and we're left with negative 6, k to the 7th, n cubed. Okay, let's take a look over here at question 2 now. So we're given the following in function notation, and we're asked to evaluate this. So that, remember, f of negative 3 means x is negative 3. So we're just going to plug in. I have f of negative 3 is going to equal, right, wherever I see an x, plug in that negative 3. So I have 2 times negative 3 to the 0 plus negative 3 to the negative 2nd. And remember PEMDAS, let's follow PEMDAS. Negative 3 to the 0, that's 1. Anything to the 0 power, right? Anything to the 0 power is 1. So we'll have 2 times 1 plus negative 3 to the negative 2nd. I want to get rid of this negative exponent, make it positive. So we'll have 2 plus 1 over negative 3 squared. That does not mean get rid of the negative in front of this 3 here. It means make the exponent go from negative to positive. So this is still negative, although it's not going to change our result in the end. Because now I have 2 plus 1 over negative 3 times negative 3 is 9. So I have 2 plus 1/9. And come on, people, we know mental math. I want to write 2 as a fraction with 9 as the denominator. 18 over 9 is 2. So we're going to rewrite this as 18 over 9 plus 1 over 9, which is 19/9. So that's my answer for question 2. All right, so for question 3, we've got 3 parts here. I'm not going to do them all. Okay, you guys got to do some of these for practice on your own. You're going to do A and B. I'm going to show you how to do C right now. So you're going to do A and B, and I'll write the final answers, but you got to do these yourselves. So, ooh, look at that. We're already starting off with that negative exponent. How fancy. So I have 4 to the negative 1st times x to the negative 3rd all over x squared y. Again, all raised to that negative 1 power. How exciting. Now remember, when you've got that negative exponent, we got to flip the fraction. So this is really going to be x squared y all over 4 to the negative 1st, x to the negative 3rd. Now we can start to simplify this. Okay, so we want to deal with these negative exponents down here. We want to make them positive. So by doing that, right, to get rid of those negative exponents, we're going to bring them up. Bring them to the numerator. Bring them to the numerator. By doing so, right, I'm just going to rewrite this. By doing so, we have now eliminated that negative exponent. And again, just continuing to simplify. We have x squared times x cubed, multiply like bases, add the exponents. 4 is just raised to the 1st, so we'll put that out front. And we have y. And that's it. 4x to the 5th, y. There you go. I'm just going to write the answers for letters A and B, but you're doing these on your own. I'm not going to show the work for it. You need to do this yourselves. So for 3a, you should get 3x over y squared z to the 4th. And for b, you should get 5a to the 4th, c cubed, all over b to the 5th. Okay, so those are your 2 answers for A and B. All right, moving on. Let's take a look. We're actually going to finish these. 4, 5, and 6. We're going to do 4, 5, and 6. All right, so for question 4, okay, so let's see what we're given here. We're given 2 to the A is equal to y. 2 to the A is equal to y. And we want to know then, what is 2 to the A plus 1 equal? in terms of y, right? Notice how everything is in terms of y here. So, how can I rewrite 2 to the a plus 1? How can I rewrite that? Any ideas? Well, remember, when you multiply like bases, you add the exponents. So let's undo that. Undo the multiplying of like bases and adding the exponents. So can't we just rewrite this as 2 to the a times 2 to the first? Right? Because if I were to re-simplify that again, multiply like bases, add the exponents, I get right back to where I was. And we know we're given, right? We're given this information, 2 to the a is y. So this here is y multiplied by 2. So it's just 2y. That's it. Okay, let's look on question 5, and then we're going to get to 6. So for question 5, we have b to the 2n plus 1, all cubed, all over b to the n times b to the 4n plus 3. Again, hey, look at that. Like bases. So I'm going to add these exponents, add them together. So I'm literally rewriting the numerator right now. I'm not doing anything with it. And I see with that denominator, keep the base, add these exponents. N plus 4n plus 3 is just 5n plus 3. And now I'm going to start to simplify this numerator. Right? Now I'm going to start to simplify that numerator. So let's see. We have, and I'm just going to I'll rewrite it down here. I've got tons of space, so b to the 2n plus 1, all cubed, all over. Denominator is now simplified. Remember, we can expand this, or we can multiply our exponents, right? Exponent to the exponent, multiply, because this has the power to a power rule. So we can write this as b to the 3 times 2n plus 1, all over b to the 5n plus 3. Distribute. I'll get b to the 6n plus 3 over b to the 5n plus 3. And now this might look a little strange, but this is nothing we can't handle. I have like bases being divided. What's our rule for dividing like bases? What do we do with the exponents? Subtract. So I've got b to the 6n plus 3 minus, right, subtract the exponents, minus 5n, minus the 5n plus 3. I'm going to distribute. Okay, so again, this came from using the fact that when we divide like bases, we subtract the exponents. So what that it's a binomial? Who cares? All right, and let's see. Let's rewrite this here now. Okay. We'll have b to the 6n plus 3 minus 5n minus 3. Just distributing. And let's see. 3 minus 3 is gone. 6n minus 5n is just n. So I'm left with b to the n. Answer choice B. Fantastic. Last question is number 6. So for question 6, we have 12x to the negative second, all over 3x to the negative first, whole thing in parentheses. Careful, I almost just did it wrong. Got to write it correctly. Okay, I want to get rid of this negative exponent, so I'm going to rewrite this as 12 over, move this to the denominator, as x squared times 3x to the negative first. And now this whole thing is going to move to the numerator, getting rid of these negative exponents. So we'll have 12 times 3x to the first. Now, do I really need to write that? No. Come on, you're in advanced math concepts. We know this stuff. All over x squared. I have 12 times 3 is 36. Don't forget the x. And I've got one more x on bottom than I do on top. So there we go. 36 over x, and we're done.